So today we're going to go ahead and talk about polynomial division, dividing polynomials. We talk about that for a couple of reasons. One of them is because after we talk about polynomials, we're going to talk about rational functions, which are fractions with polynomials in the top and bottom. And fractions are division problems. So understanding how polynomial division works will help us with the rational function issue. Second, this is one way to factor a polynomial that is bigger than a quadratic. Because if you can guess what one of the factors is, you can divide it out, and that makes the polynomial smaller, and maybe you can factor the answer to that question. Yeah? So something that started it out not factorable becomes factorable as we pull factors out of it. So I'm going to do a quick review with some numbers, because this process works exactly like long division on big numbers. It is the same algorithm you used way back in like 4th grade when you first learned long division. And never used it, well, you're going to use it now. So we're going to review. So I want to divide 1683 by 7 for funsies. Pulled two numbers out of thin air. I don't know if it divides unevenly, but I do know that I can't just do that in my head. So we're going to do some long division. Review of some terms. The thing in front, the thing that is being divided into, is called the dividend. The number in the back, the one that is being divided into the other number, is called the divisor. If I were to write this division problem as a fraction, the dividend would be the numerator, the divisor would be the denominator, top and bottom, front and back. Yeah. I want to write this as a long division problem. And the question is, where does the dividend go? Inside or outside? Inside. I made my line too long. Divisor goes outside, dividend goes inside. Very good. Start in the first place. Does it fit into 1? No. Does it fit into 16? Yes. How many times? 2. It's in 2 times. 2 times 17 is 14. I need to find the difference. It's 2. What do I do next? Perfect. Bring down the next term. 7 goes into 28. 4 times exactly. 4 times 7 is 28. 0. Bring down the 3. Does 7 fit into 3? No, and I've got nothing else to bring down. I should add a 0, which is 0, which is 3, which is my remainder. Yeah. Right, and I'm not going to do decimals because polynomials can't have decimals. So we're going to stop with our remainder. So the answer to that division question, I was asked, what is 1683 divided by 7? The answer is 240 and 3/7. We write our remainder as a fraction over the divisor. So some new terms. We know dividend and divisor. That is my quotient, except that's not how you spell Mr. Joel. The number on top is my remainder. And which number is in the bottom of that fraction? The dividend or the divisor? That's the divisor, yeah. So when I go to make the fraction that represents my remainder, it's remainder over divisor. That same pattern is going to hold for polynomial division. The order that we performed those steps in is the same process we're using for polynomial division. The step list here is the same as the step list we're about to go through with polynomials. So if you can remember that procedure, it's the same mechanics, but now it's got letters in it. Yeah? Okay, so let's work through an example with a polynomial. Nice deep breath. Come on. Why is it not cooperating today? This TV hates me. So first step says set up the division problem. 5x squared plus 3x minus 2 divided by x plus 1. Dividend on the inside, divisor on the outside. Yeah. Second step is the same idea. I'm going to go term by term, and I'm focused on the leading term in my divisor. I don't care about what comes after it, just the leading term. Leading term in my divisor is x. So I'm focused on x. How many times does x fit into 5x squared? And the answer is 5x, right? I am going to write that 5x above the linear term in the dividend. I want those like terms to line up in the dividend and the quotient. Nope. The next step is the same as it was before. We're going to take that number we just wrote in the quotient, multiply it by our divisor, and write the answer. So 5x times x is 5x squared. 5x times 1 is 5x. I'm assuming I've done that multiplication correctly because nobody's yelling at me. And Ellen's nodding. That's good. Okay. Now that I've done the multiplication, what do I do with those two lines? Same step we did with the number division. Subtract. Yeah, subtract. And I'm going to put parentheses around here to remind myself that I'm subtracting each term from the one above it. Subtraction all the way across. 5x squared minus 5x squared is what? 0. If we've done this correctly, usually these will cancel. Gone. Yep, gets erased. 3x minus 5x is minus 2x. Yes, assuming that I did that correctly. Oh, Brandy came back. What do I do next? Bring it down. Very good. So minus 2. And then we repeat. So I repeat the process. How many times does x fit into negative 2x? The answer is negative 2. Yeah. And then I multiply. Negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. I subtract. And what do I get? 0. And you'll notice there's nothing left to bring down. So this is where I stop. That's the end of the process. And because there is nothing there, I have no remainder. X plus 1 divides evenly into 5x squared plus 3x minus 2. So for my answer, I would write that 5x squared plus 3x minus 2 divided by x plus 1 is equal to 5x minus 2. We will talk about shortcuts later. There are sometimes shortcuts, not always. This one is one that has a shortcut. There's one, and we'll talk about it in a minute. But you need long division because that shortcut doesn't always work. So we're practicing both. Yeah. How do I undo division? What's the opposite operation? Multiplication, meaning I can rewrite this as my original function, 5x squared plus 3x minus 2 is equal to 5x minus 2 times x plus 1. I've just factored my trinomial. If you know one factor, you can drop the power by 1 and maybe factor what's left over. Or if it was a quadratic, when I drop the power by 1, I end up fully factored. Which makes us happy. Yeah. So what I would like to do is I would like to do 2 more examples and then talk about the shortcut. Are you okay with that? Yes? Everybody looks so wide awake. Yes, Bruno? Because if you FOILed this out, you should get back to where you started. Yeah? Okay, so that's some book talk, which I'm not too terribly worried about. I want the example, which says divide 6x cubed plus 11x squared minus 3x plus 15 by 3x minus 2. So the first thing I know, just looking at the structure of that problem, what is the degree on the dividend? 3. That's a degree 3 polynomial. X cubed is the biggest term. What is the degree on the divisor? 1. 1 linear is a degree 1 polynomial. Good, Brandy. We don't write it when it's 1, because x to the 1 is just x, just like 5 to the 1 is just 5. Just one of them. When I do this division, if I'm dividing by a degree 1, it's going to drop the exponent on all of those powers of x by 1. I'm going to end up with a quotient that's x squared, because I'm dividing an x out of all of those terms. It's functionally what I'm doing. Let's try the long division. So dividend inside. And I did not account for how big my handwriting is. Divisor outside. Focused on the leading term of my divisor only. So that 3x. 3 goes into 6 twice. X divides into x cubed. I'm going to get an x squared. So I'm dividing the 6x cubed by the 2x. 3x, sorry. And then I multiply. 2x squared times 3x is 6x cubed. 2x squared times negative 2, negative 4x squared. Assuming I did that correctly. Good. And then I subtract. So 6x cubed minus 6x cubed cancels. 11 minus a minus 4. Minus minus becomes plus. 11 plus 4 is 15. I see some nodding. Very good. Jordan, what do I do next? Good. Bring the next term down. Perfect. So minus 3x. And then we start over again. How many times does 3x divide into 15x squared. So 3 goes into 15 how many times? 5. It's a positive 5. And x squared divided by x should be x. Because if I reverse it, x times x gets me back to x squared. Pretty sure I did that correct. And then we multiply. So 5x times 3x is 15x squared. That's the check we did this correctly. 5x times negative 2 is negative 10x. Come on, pen. I'm doing my best to not curse at the TV. 15x squareds cancel. Negative 3x minus negative 10x. Positive 7x. Very good. Last step, I bring that 15 down. How many times does 3x go into 7x? 2 plus 2. 2 times 3 is 6x. 2 times negative 2 is minus 4. And I'm going to subtract. And what am I left with? I agree with the x. I agree with the plus. 15 plus 4 is 19. X plus 19. Good. That is the end of the process because I don't have anything left to bring down, which means this is my remainder. To build my answer, I'm going to do it like I did it for numeric division. I know my answer is the quotient, not 5, 2x squared plus 5x plus 2, and then the remainder as a fraction, plus x plus 19 over 3x minus 2. Same pattern, quotient, remainder over divisor. Quotient, remainder over divisor. Yeah. Starting to feel more comfortable? Very good. That's fair. That's fair. If it makes you feel better, when I first learned long division in 4th grade, it took me an exceedingly long time to learn how to do it. I was very bad at it. Oh, well, I was not very good at it when I first learned. All right, we're going to do one more, and then we're going to learn the shortcut. We're going to go around the room. I'm going to have some people help me. Gabe, can you tell me how I start? Very good. Gold star. X minus 5. Very good. Alex, what do I do next? Is that a you're stuck and you need help? Jade, can you help your neighbor? What do we do next? Perfect. How many times does x fit into x cubed? If I divide x cubed by x, I'm going to be left with x squared. I'm taking one of them away. So that's 1x squared. And the check is if I multiply, I should get back to where I started. X squared times x is x cubed. And then x squared times negative 5 is negative 5x squared. Yay, Lucero, what should I do next? Perfect. Yeah, subtract those two lines. X cubed minus x cubed is 0. Negative 4 minus negative 5 is just positive 1. Yay. Very good. Dayanara, what do I do next? Very good. Drop the negative 26. Oh, something feels very wrong there. What's missing? An x. Yeah, that shouldn't be there. Now what? And the answer is, I'm going to go put a placeholder in for the term that should have been there. Yeah, I need a placeholder. If your dividend is missing a term, stick a 0 in as a placeholder. I mean, our answers to line up. The upside is the question we're trying to answer is fairly easy. Gerardo, what do I do next? Very good. Which would be how many times? Right idea. Your right idea. There are two x's there. I'm dividing one out. I'm left with 1. Yeah? Huh? Yes. I would leave your stuff unless you're confident you're leaving. It would be nice if you made an e-haul pass before you left. We do the multiplication. X times x is x squared. X times negative 5 is minus 5x. I'm looking frowny face. That. What do I do next? X squared minus x squared cancels. 0 minus a minus 5x becomes a plus 5x. I don't see any arguments. Cecilia, what should I do next? Bring down the next term. Perfect. How many times does x go into 5x? 5 times. 5 times x is 5x. 5 times negative 5 is negative 25. And I subtract. And when I subtract, what do I get? Positive or negative? Negative, very good. Negative 26 plus 25 is negative 1. So I have a remainder of negative 1. Very good. Very good. So my answer is x squared plus x plus 5. My remainder is negative, so minus 1 over x minus 5. How do you face? Yeah. Yeah. Yay. I am hoping that feels a little bit more comfortable now. We've seen it a couple times. Yeah, a little bit. There are some cases where we need to do long division. There are special cases where there is a shortcut method available. So that's the next thing we're going to talk about is our shortcut method. Yes, Bruno? Why is the long division for this and that's not level 2? Why is the what? How, what? Because I think you guys in pre-calculus should be capable of level 2. Jala speaking. I'll send her down. Bye. Jade, that was for you. I'm sorry. We will miss you, friend. All right, back on track. The shortcut method is called synthetic division. Give me a thumbs up if you've heard of synthetic division before. I see fewer thumbs up than I should, which makes me a little worried about what happened in your Math 3 class. We should have gone over this. The requirements for synthetic division. Your divisor has to be a binomial. So this doesn't work if I'm dividing by something bigger than a binomial. I can't divide by a trinomial or something with 4 terms with this method. My divisor has to be a binomial. Words are hard. Specifically, a binomial in the form x minus k. X minus k, where k is a constant. It's just a number. So some of the problems that we did in our previous examples followed this pattern. We could use synthetic division. One of them didn't, because it had a coefficient in front of the x. In synthetic division, the only thing we keep track of are the coefficients on the polynomials. We don't have to drag the x's around. We don't have to worry about how many times 3x fits into 6x cubed. And we're going to do some examples. I'm going to do one, we're going to do one, you're going to do one. So first step, after we've checked that synthetic division is appropriate, is we write down k for the divisor. So remember that the pattern we're matching is x minus k. For our example, the divisor is x minus 3. What is our k? 3, yeah. First thing I'm going to write down, upper left corner of my problem-solving area is a 3. Then I'm going to make a box, specifically the left edge and bottom edge of a box. Oh, you had to leave early. And then I'm going to do step 2, which is write the coefficients of the dividend in the box. If you are missing a term, you need to put 0 as a placeholder. I have a squared term, a linear term, a constant term. I'm not missing anything in between. So I'm going to copy just the coefficients. 5, negative 3, negative 36. Just the coefficients. And we do a 2-step process. Bruno, focus. Focus. We're going to bring down the coefficient. Technically, what we're doing is we are adding down the column first. And then we are going to multiply the result and bring it up. So that first column, there's nothing beneath the 5. So 5 plus nothing is just 5. That first column's always just going to come straight down. To get the number that goes in the next column, I take that 5 and I multiply it by my k. In this case, my k is 3. What is 5 times 3? 15. I'm glad some of us are awake. Very good. And then I repeat this shoestring over and over again. Add, down, multiply the result by k. Add, down, if there's another row, multiply by k. So, negative 3 plus 15 is 12. Assuming I can do math. I'm going to take 12, I'm going to multiply it by 3. 12 times 3 is 36. I add down, negative 36 plus 36 is 0. When I do synthetic division, the very last number in the series is my remainder. Very good. And because the remainder is 0, we know that x minus 3 divided evenly into the original polynomial. So the answer to the division question is this polynomial here with these coefficients. The polynomial in your answer, the quotient, should be 1 power less than the polynomial you started with. What was the degree on the original dividend? 2, meaning my answer should be degree 1. It's a linear. My answer is 5x plus 12. 5x squared minus 3x minus 36 divided by x minus 3 is 5x plus 12. No remainder. Yeah? Good? Okay. Do one more together. I'm going to have you try one in your small groups. All right. Next one says divide. Divide 4x cubed plus 10x squared minus 6x minus 20 by x plus 2. Notice that my pattern for synthetic division is x minus k. That's positive. It's changing sign. My k is negative 2, 4, 10, negative 6, negative 20. And I'm going to do this rapid fire. Bring the first coefficient down, bring down the 4. And then I'm going to multiply and add, multiply and add, multiply and add. Negative 2 times 4, negative 8. 10 plus negative 8 is positive 2. 2 times negative 2 is negative 4. Negative 6 plus negative 4 is negative 10. Negative 2 times negative 10 is positive 20. Is 0. My remainder is 0. Way faster than long division. Add down, multiply by k. Add down, multiply by k. Add down, multiply by k. The whole process until we get to that last column. Reminders that this guy is the remainder. This guy are the coefficients on my quotient. So the answer to that division question, what was my degree of the original polynomial? 3, so this is degree 2. 4x squared plus 2x minus 10. Your answer should be 1 degree less than the degree you started with in your dividend. Because we're dividing by a linear. It's going to drop the powers by 1. Good. I want you to take the remainder of class. In your notes, I want you to try example 6. I'm going to come around and see how you are doing. While you are working on example 6, I would like to remind you, you have some delta math this week. Homework 3B in delta math is practice with both long division and synthetic division. The rest of this week, we are practicing features of polynomials and polynomial division. Yay.